current tidal theory is based on the idea that tides are volume waves generated in the area of the equator. Volume waves involve the entire height of the ocean, while surface waves produced by the wind involve a depth of only a few meters. The volume wave propagates at 800 km per hour in the 5,000-meter mean deepness of the Atlantic Ocean. Such a scenario is fully incompatible with the time schedule of high tides in Brest, in France, compared to the Moon position. In reality, there is a general swelling of the high sea level from the equator up to 50 degrees north and south latitude. In the continental shelves, where the depth is much lower, the tides are volume waves. There are two generating accelerations: the gravitational effect of the Moon and the gravitational effect of the Sun. The effect of other planets is completely negligible. The gravitation of the Sun and that of the Moon are greater on the side of these stars than at the center of the Earth, and weaker on the other side of the Earth. The inertia of the Earth generates centrifugal accelerations in reaction to the gravitational accelerations. The center of the Earth is therefore in a state of weightlessness in its rotations around the centers of gravity of the couples Sun and Earth and Moon. The rotation of the Earth's center around these centers of gravity does not imply any angular momentum. There are no links between the Earth center motion and the Earth angular momentum. Thus, the centrifugal accelerations balancing the effects of the Moon's and Sun's gravitation at the center of the Earth are the same everywhere on Earth. The ocean tides result from the vectorial combination of the gravitational acceleration of the Sun and the Moon on the surface of the Earth with the centrifugal accelerations associated with the center of the Earth in its revolutions around the center of gravity of the two couples made up of the Sun and of the Earth and of the Earth and the Moon. The centrifugal accelerations are therefore greater than the gravitational accelerations on the surface of the Earth on the side opposite the attracting star and weaker on the other side. So there is a bulge on each side of the Earth twice a day, i.e. two high tides. The effect of the Moon is about 5 times greater than that of the Sun. The ground of the Earth is of course subjected to the same accelerations. The time schedule of tides is mainly a result of the position of the Moon. Oceanic tides are an overall swelling of the ocean up to latitude as high as 50 degrees north and south. The speed of the swelling from east to west is about 1,800 km per hour at the equator. This is the speed of the Moon with regard to the surface of the Earth. This swelling generates a volume wave at the cliff edge of the continental shelf. This volume wave propagates at speed of tsunamis through the continental shelf, square root of g by h equal 138 km per hour for an ocean deepness of 150 meters. The height of the volume waves is increase accordingly. This explanation is the only one compatible with the delay between the time swelling is produced and the time the high tide occurs in Brest in France. This delay is about an hour and a half. This is precisely the duration needed for a volume wave to propagate through the continental shelf when the sea is about 150 meters deep. The related height of the volume wave is increased up to some meters only because the ocean widens in the Gascoyne Gulf. According to the mean deepness of the continental shelf, the high tide should occur in Saint-Malo, in France, 2 hours later than in Brest, 10 minutes before in La Rochelle and 30 minutes before in Saint-Jean-de-Loire-Louse, near the Spanish border. In fact, this is not that easy. Ocean tide is an intricate problem. But the replacement of the wave propagation hypothesis by an overall swelling opens a way to explain the rather more intricate problem of tides in the Pacific Ocean. Although that ocean is divided in 3 vertical zones so that it could be analyzed in 3 steps. Here are the January, March, and June 2008 tide curves for Brest in France. The first curve of each month gives the high tide for each day of the month. The other one gives the related French coefficients.